Okay, so welcome back, and now we're going to talk more about the area under the curve. And so let's recap. So we talked about net signed area. Okay, and so we can talk about how we subtract the areas if the area is below the curve versus above the curve, right? We subtract those, and that gives us the net signed area. Now this is great for a lot of physical applications. For example, if we want to get displacement, we can find the displacement of a car, so how far a car has traveled. So remember, the integral of the velocity function gives us the position function. So, but what is the integral? The integral is the area. So when we look at a graph of velocity over time, we can find the distance the car has traveled by looking at the area. So if we wanted to know the displacement of a car, so again, how far the car is from its original starting point, then we could use the net signed area to give us displacement. All we would have to do is take the area of under the velocity curve and subtract that's above the curve and subtract it from the velocity, the area under the curve for below the t-axis. So for example, here we're going to assume constant velocity, so that's the easiest one to deal with because we're just dealing with a rectangle. So if velocity is constant, then it's just the area under the curve is just a rectangle. So really easy to calculate. And so we can find the distance the car traveled by looking at constant velocity, right? So distance equals rate times time, right? For constant velocity, easy algebra. We just use the formula. So in this case, it's 70 times 2. So 140 miles. Okay? Now, in the case of displacement, then what we would do is look at, like for example, in this case, the car drives, let's say, due north at 60 miles per hour for 2 hours, and then drives due south at 40 miles per hour for 3 hours. And so we can find the displacement by using this area and this area and then subtracting them, right? Just like we talked about before. And again, because these are constant velocity problems, we can just use algebra. Okay? So this turns out to be, so again, if this is A1 and this is A2, right? So then the integral from t equals 0 to t equals 5 hours is just going to be the area of A1 minus A2, like we talked about before. And so if we find this area here, this is just going to be 60 times 2 minus 40 times 3. And so this gives us 120 miles minus 120 miles, which equals 0. So what does it tell us? The displacement is right where it started. So the car is right at its back at its starting point. Okay? But what if I wanted to find the total distance that the car traveled? Then what I would do is I would add these two areas. Right? Because I would treat the areas are positive, always positive. But instead of subtracting the area underneath the curve from the area that's above the curve, or above the axis rather, I would just add them, right? Because I want to get total distance traveled, right? Even though displacement is 0, the total distance traveled in this case would be 240 miles. And so now we have another quantity that we can talk about and figure out. Okay, so so in this case here, if we look at the formula, so for example, so let's go back to this. So this example here, we would write this as the integral from 0 to 2 of what? It's going 70 miles per hour, right? And so the velocity function would be just, it's a constant velocity, so it's just 70 dt. And so in this case here, because it's just constant velocity, it's just equal to 140 miles, right? Just like we said. And then of course here, we would do this 2 steps, right? So it would be 0 to 2, right? So for the first part, so it's going due north at 60 miles per hour, so it'd be constant velocity, so it'd be 60 dt from 0 to 2, right? And then we would add the integral from 2 to 5, and it's now going negative 40 miles per hour dt. And of course, this is going to equal what? 120 miles plus a negative 120 miles, which gives us the same answer that we saw before using algebra. Okay? Now, if we wanted to find the total area, right, which means the total distance traveled in this context, then what would we do? Here's what we're going to do. We're going to add, the easiest way to think about this, as I said before, is to think of calculating total area by adding just the areas that are above and below the axis. Okay? That's all we're doing. Remember, area, when we talk about area in the physical world, it's always positive, right? So to get total distance or total whatever, total area, then all we have to do is just add the areas that are above and below the axis, and that's it. Okay? So to do that, mathematically though, what do we have to do? We have to put absolute value signs around the integrand. That'll do it. So then, if we wanted total distance traveled, then what would we get? We would get, what? 120 plus 120. Because we're doing absolute value now with an addition. Here, when we didn't have the absolute value, it was plus a negative, right? And so we got 0. Here, now we get rid of the negatives and we're just adding up all the zeros to get the total, and in this case, total distance traveled, which gives us the 240 miles that we got before. Okay? And so that's how we're going to use the integrals. And so next is, I'm going to introduce the definition, which is going to summarize all of this, and then we'll move forward. Have a great day.